my name is Kaylee Sherwood, and today I'll be doing a tutorial on XFLR5 to simulate a NECA airfoil so that I can display the CD versus alpha, CL versus alpha, and other corresponding plots to analyze and yeah, just study. Um, so let's get started. As you can see, I already have XFLR5 open. Um, when you open it, it just displays a blank screen. So to actually start our study, I'm going to go to Module, and then I'm going to click Direct Foil Design, which will open this plot that we see here. And like I said, we're working on a NACA 4412. So I want to actually input that into this graph. So to do that, I just have to click Foil, and then I go to NACA Foils, and I put 4412. And so something just to preface here is that you'll notice that this airfoil has 4 digits, and each one is pretty important in the way that it defines just the characteristics about the airfoil. And so the first digit is the 4, and you can notice that it indicates that there is a maximum camber length of 4% of the chord length. And then the second digit is also a 4. And that indicates the location of the maximum camber, which is going to be 40% from the leading edge of the airfoil. And then lastly, those last 2 digits, the third and the fourth digit, they are grouped together. And they actually help to define the thickness of the airfoil, which is going to be 12% of the chord length. So those are just some helpful things to know with your airfoil. But since I have everything kind of already set, we're ready to go. And then I'm going to change the number of panels to be 200. Sorry, 200. And I'm going to click OK. And then once again, I'll click OK again. And you can see your airfoil. So this is just what it looks like generally. And now that we finished setting it up, we can actually move on to analyzing it and studying it. So the next thing that we need to do is we're going to go to Module again, and then we're going to click Xfoil Direct Analysis. So I'm going to click that, and once that happens, you'll see that it opens a ton of plots, which are going to be extremely, extremely, extremely helpful for us because this is what we want. Like this is what we want to be displayed. At the end of our simulation, we already see our CL versus CD, we see CL versus alpha, CD versus alpha, and those additional 2 at the bottom, which can be changed as well. And you'll also notice, let me move myself over. You also notice in this right corner over here that there are some angles of attack. But before we can actually edit those or change them, we need to actually define our analysis. We need to define what is the laminar, what is the Reynolds number? Is it laminar? Is it turbulent? Is it with this Mach number or this Mach number? There's so many different things that need to be defined so that we can actually figure out what our graphs are going to look like. So I'm going to go to analysis, and then I'm going to click define an analysis. And so you'll see this thing pops up in the middle, and it just gives the rundown of all the different things that it's going to play into our simulation. For my specific simulation, I want to have turbulent flow, and I want a Reynolds number of 1,500,000. And so I'm going to keep all of this stuff the same. And if I needed to change my Reynolds number, this is where I would do it. If I wanted a laminar number, I would just change it. If I wanted a different turbulent number, I would change it here. And I don't want to specify my Mach number. I don't need to change any of these other things down here. So everything looks great to me. So I'm just going to click OK. And then back to this right corner over here. Let me try to make it a little bit bigger so that you can see. You see, we can actually alter our angle of attack range, which is super helpful. We can study data in so many different ranges, which is so helpful. We can make the increment smaller, we can make it bigger, which is all super useful stuff for us. And so I'm going to be creating some graphs from the range of -5 degrees to +20 degrees, and I want an increment from each of those angles of attack to be 1 degree. However, like I've mentioned before, if you wanted to change or alter any of this data, all you would have to do is, if you want a different start, you would just change it. If you want a different end, you would change it. And if you want a different increment, you would click this delta and put whatever you wanted. And so all our analysis is set up. So the last thing that's left is just to analyze it. So I'm going to click Analyze. Okay, a lot of stuff popped up. Let me hide this again. Um, Let me move it over here, actually, sorry. And you'll see that all of our graphs got filled in, which is great because this is exactly what we needed. We have our CL versus CD, we have CL versus alpha, we have CD versus alpha, and then we have those two at the bottom. And so, yeah, this kind of shows how our, Reynolds number affects our lift and drag. It shows, just different things about the airfoil, which are helpful to know. And something that is also helpful with XFLR5 is that if, let's say, one of my graphs that I wanted wasn't displaying, all I would need to do is right click, and then I would go to current graph, and I would define graph settings. And this gives me the option to change any sort of parameter of my graph for like the X and the Y directions, and change it so that whatever I want to be displayed can be displayed. And so I don't need to do that because the three graphs that I'm aiming for are here. But the last thing that would be left is to simply just export the data. So once again, I would right click. I'm going to go to current graph, and I'm going to go to export graph. And this is my, let me move myself. This is my CL versus alpha. So I'm just going to say CL versus alpha. And I'm going to say tutorial. And I'm going to say, sorry, turbulent. And then I'm going to save it. And give me one moment, and then I'll open and show what the data looks like exported into Excel. Okay, now you can see that all of the data that was previously displayed in XFLR5 is now imported into Excel numerically. So we see our alpha, which ranges from our -5 degrees to 20 degrees, and then we see our CL, which ranges from these numbers. And it's super easy to plot them if you wanted. And I can show you super fast. So I'm just going to go to Insert. I'm going to go to Charts, the scatter chart, and I'm going to click the second one, which is in the middle. And that's just going to give me a blank graph because I need to define the information that's going to be displayed. So I'm going to right click, I'm going to go to Select Data, and then I'm going to Add Data. And because this is our CL versus alpha, I'm just going to specify that CL versus, oh, I don't know what happened. Sorry, CL versus alpha. And let me go back over here. And on the x-axis, I want our alpha, so -5 to 20 degrees. And then for our y-axis, I want all of the values for CL. So I just click them all, and I'm going to select OK, and OK again. And then you'll see our data is displayed. And this graph looks almost identical. Well, it basically is identical to the graph that is displayed for our CL versus alpha graph on XFLR5. And if you wanted, you could add a trend line here. I'll just add one really fast. And you can see that. But yeah, I hope that this tutorial was helpful and thank you so much. Have a great rest of your day. Bye.